Alright, so when you guys are taking the Algebra 1 STAR test, you're going to have word problems you got to deal with. So in the Khan Academy, we have some linear equations that deal with word problems. They've given you a table. All you got to do is look at the table and use the table to help you interpret what you're trying to find. Alright, so it says the price of a climbing trip to Mount Kilimanjaro includes an initial fee. Whenever you're reading a word problem, the initial fee is always the y-intercept, okay? So I'm going to label that. That's the y-intercept. Plus a constant fee per meter. Every time you see something per meter or per mile or per something, that's called a rate. So that's going to be dealing with our slope. All right, so the table compares the total distance of a trip and the price of the trip in dollars. So this is kind of saying this is your x values, these are your y values. All right, so when you're making your table, that's what you're going to do. So it says, how far can you climb for $131? So basically, think of it this way. You're going to put 131 in this column because 131 deals with the price, and what you're looking for is you're looking for this value. Okay. So we're going to use this, and we're going to make a table in Desmos. All right. So you're going to make a little table in Desmos because you'll be allowed to make a table. So we're going to make that the x1 and the y1. So we're going to make a little table in Desmos. We're going to put all these numbers right here, okay? Now I'm just going to put a couple of them because we're going to also do this by hand. Okay. All right, and we got 110. We got 119. Okay, 0.30. All right, so let's go ahead and make a table right now. Go to my Desmos. Make a table. And we'll go back and type in 80. All right, let's do it with my computer. 115.40. All right. And what do we have? We have 110, 119.30. And you don't need another point, but we're just going to put it in there. 140, 123.20. 40. All right, let's make sure I got it right. 80, 115.40. Yep. Okay, now that you typed it in correctly, you can type in the phrase that pays, y1. You got to put the little tilde. All right. mx1 plus b. And what this does is it allows you to have what's called the slope and the y-intercept. So there's the slope and the y-intercept that goes with this table. All right. Okay. So right now, you could type in y equals 0.13x plus 105, and you'll see, if we zoom out enough, you'll see that that it interpreted, all right, the line that it interpreted is indeed this line right here. Okay. Now, what we're trying to figure out, how many meters would it take to, how far could you climb for $131? All right. So this is your y value. So here's kind of a cool thing you could do. All right. Just go over here and just make your y value. Ready? Make your y value equal to 131. Just go over here. See where the two lines intersect. Why is it not? Hold on. Right there. Boom. It intersects right there at 200. So that's going to be our final answer. All right. So if we wanted to figure out the slope, just remember, this is the change in the y, this is the change in the x. So this change in x is going up by 30. So this is the change in x, goes up by 30. Now what's the change in y? 119.30, 119.30, and what are we taking away? 115. Oh, my bad. There we go. So 3.9. Okay? 3.9. That's the change in y. So our slope is 3.9 over 30. That's the change in y over the change in x. So 3.9 divided by 30 is that 0.13. That's our slope. Okay? So that's how we got y equals 0.13x. All right? Plus, and our y-intercept was 50. All right? But if we wanted to find our y-intercept by hand, what we'd have to do is we have to basically figure out when your x value is 0, what's your y-intercept. All right? So if we want to do it if we want to figure out 50 by hand, we'd have to use our ordered pairs, which are 110 and 119.30. All right? So here's what you would have to do. I'll just use 110 and 119.30. 110, 119.30 equals 0.13 times, what was it? 110? Yeah, 110. Plus b. And when you multiply 0.13 times 10 times 110, you get 14.3. Oh, 105, not, yeah, 105, there's the y-intercept, okay. And if we take away 14.3 from both sides, that's where you get the 105. So there's our b value. Now, if you wanted to use this equation, which is in slope-intercept form, and you wanted to figure out how far you could climb, which is your x, all right, if you traveled 131 meters, I think that's what it was. Let me look. No, $131, sorry, $131. All right, so we're going to put 131 equals 0.13x plus 105. I'm going to take away 105 from both sides. All right, and you get a total of 26 equals 0.13x, and then you just divide both sides by 0.13. All right, so 26 divided by 0.13 is 200. Now, that's just doing it by hand, but you have access to Desmos, all right, which means you can create the table, find your line, and put y equals 131 and see where the two lines meet, which is 200. All right. Let's see if there's an easier way by hand. Okay. All right, so here it happened to go up perfectly by 30 each time. And each time it went up 30, it went up a $3.90. And so they just added 30 here and added $3.90 there. Okay. So they just kind of continued the table. All right. And by adding 390, you got 130, 131. All right. On this one, it says Julia got the delivery order, and she took some time to get ready. Then she rode her bicycle at a constant speed. The table compares the distance Julia made in kilometers and the time since she got the order in minutes. How long did it take Julia to ride 1 kilometer? All right, so we're looking for a speed or a rate. Okay, so this rate is like how long. So right here, this is dealing with the change in y. Those are y values. This is your x. These are your x values. So it says how long. So we're looking for the change in y over the change in x. So we're looking for how long it took her to ride what? 1 kilometer. Like how long did it take? All right, so let's see if we can find the slope here. We'll figure it out. So the slope is always the gap in the y, so the change in y. So it looks like it goes up by 12. So the change in y looks like it goes up by 12. The change in x goes up by 2. So the change in y over the change in x is 12 over 2, which is 6 over 1. So what does this mean? So what does this 6 over 1 or 6 actually mean? It means this is the change in the time. So in basically 6 minutes, okay, in 6 minutes she can go 1 kilometer. All right, in 6 minutes she can go 1 kilometer. In 12 minutes she can go 2 kilometers. In 6 minutes she can go 1 kilometer. So how long did it take Julia to ride 1 kilometer? It looks like it took her 6 minutes to ride 1 kilometer. Let's see if that's the answer. We got it. All right. I only did a couple of problems, but I'm going to go ahead and do a couple more. All right, let's take a look at this one. Now this one's, it looks like it's very similar. We have Julia got a delivery order. She took some time to get ready, and then she rode her bike at a constant speed. So just so you guys know, the time that she took to get ready, that's the y-intercept. Okay, the time that she took to get ready, that's called the y-intercept. Her riding at a constant speed, whatever that speed is, that's the slope. Okay. All right, that's the slope. Now it says, how long did it take Julia to get ready? So what are we looking for here? We're looking for what's called the y-intercept. All right, so I'm going to make a table here, except we're going to work our way backwards, okay? So we have a 10 and a 70. And then we have an 8 and a 58. Then we have a 6 and a 46. Okay, but if we work our way backwards, okay, let's think about this. Without having to do a bunch of math, let's think about our gaps. These are a gap of 2. I'll make a x-axis. Sorry, not x, sorry, x and y table, not axis. My apologies. So this goes up by 12. This also goes up by 12. So it looks like it's the same rate. So our slope is still 6. But let's work our way backwards. So if I go to a 4, let's take away 12 from that. So what's 46 minus 12? Is that 34? All right, I think so. Yeah. 46 minus 12. 34. Let's take away 12 again. 22. All right, so we go to 22. We go back 12. All right. Because it gives us at a 2, then we get to 0, go back 12. Whew, puts us at a 10. So right here, that's our y-intercept. If we kind of just use the table and work our way backwards, that's kind of just a logical way to do it without having to do a bunch of math, okay? But if you like Desmos, which you're allowed to use, okay, let's just change things up, okay? So right now, I'm going to clear this out. There's your graphing calculator. Let's go to Desmos. We already have y1 tilde mx1 plus b. Let's just go to Desmos and just change our numbers. I think this was a 6, this was an 8, this was a 10, and then over here we had, let's see what we have here, 46, 58, 70, 46, 58, and then 70. Okay, so listen, you can put it into Desmos and it gives you the slope and the y-intercept. You got to hit home to be able to see it though, okay? And so what we're looking for is, we're looking for the y-intercept. So it's very easy to type it into Desmos, find your slope, find your y-intercept, but you have to know what you're looking for. So when it says she got a delivery order and it took her some time to get ready, you have to know whatever time she took to get ready, that's a constant. That's not going to change. That's the y-intercept. How fast she rides her bike, that's the slope. So how long did it take her to get ready? You have to know that would be what you're looking for. You're looking for the y-intercept. If you don't know that, you can't get the problem right. Okay, let's do another one. Ying Ying wants to buy some petunias. The table compares the number of petunias that Ying Ying could buy and the money that would remain in her wallet. Okay, so right now it says, what is the price of one petunia? So literally you're looking for the slope, like what's the price for one? So let's take a look. This would be very, very easy. Here's the money. Here's the petunias. Okay, so this is your X. This is your Y. What is the price of one? Not two, but one. So here's what we got to do. We got to find the slope, or the change in the Y over the change in the X. So you'll see how much the money, what happens. The money goes down. It goes down $1.50. Okay? And then the petunias, looks like that goes up by 6. So here's the slope. The slope's negative, but the cost of it's just going to be a positive cost. So we're going to put negative 1.5 over 6. Find the slope. All right, let's do it. So 25 cents. So each petunia, it's like her, she's losing 25 cents per petunia. All right? So that's what but you're not going to put negative 25 cents. You're just going to put 25 cents because that's the price of one. So why is the slope negative? Because the money is what? The money's going down, but the cost of a petunia is just the cost of a petunia. All right? All right. All right, so here we go. Last problem I'm going to do. It says Natsumi paints walls for a living. She paints at a constant speed. Well, what does that mean? Oops. The constant speed is the slope. So this is the slope. And then she takes a constant amount of time to clean up. Well, the constant amount of time she takes to clean up, that's the Y-intercept. So I'm just going to label a couple of things in case you're writing stuff down. That's the slope. And this is the Y-intercept. All right. The table compares the total area she can paint in square meters and the time it takes her to finish painting and clean up in hours. So if she paints 30 square meters, it takes her a total of 2 hours. If she paints 45 square meters, it takes her a total of 2 hours and 75 or 2.75 hours. So how long does it take Natsumi to clean up after she's done? So what are we looking for here? We're not looking for how long it takes her to paint something, but how long it takes her to clean up. So we're looking for the what? Looking for the Y-intercept. All right, that's it. Looking for the Y-intercept. So what's the Y-intercept? When the X value is equal to 0. All right? When the X value is equal to 0. Well, would you agree that the gap between 30 and 60 from here to here, not from here to the 45, but from here to here, that's a gap of what? That's a gap of 30. So what's the gap right here? That gap from 2 to 350 is what? 150. So if I jump all the way back, I go to 0. What do I got to take away from 2 hours? I got to take away 1.5 hours. And it leaves me at what? Half of an hour. So how long does it take her to clean up? 0.5, also known as 30 minutes. If they said how many minutes, you'd say 30. If it says hours, what is it? Half of an hour. Now let's say you didn't know that, but you knew you're looking for the Y-intercept, but you didn't know how to do it by hand. That's okay. Just go to Desmos. All right? Go to Desmos. I'll type in a 30, and then a 45, and then a 60. And I think here we had a what? We had a 2, then we had a, what did we have? 2.75. And then what do we have? 350. All right, 350. And look, see my Y-intercept right there? 0.5. There's my Y-intercept. So it takes her half of an hour to clean up. So it is important to know what you're looking for. Just remember, if it's painting at a constant speed, that's dealing with the rate, so that's the slope. If it takes her a constant amount of time to clean up, that's dealing with a Y-intercept. And that's all you're doing. All right, so make sure you know if you're looking for the Y-intercept, are you looking for the slope, are you looking for a point on the graph, are you looking for the X-intercept? That's what you got to figure out when you're doing these. Hope this was semi-helpful.